My name's Laura Lee. I've been at the University of Birmingham for 8 years now. So I did the undergraduate masters in chemical engineering, and now I'm just finished a PhD in formulation engineering. During my undergraduate degree, I worked for 2 companies, a water treatment company and then a food research and development company. This is PepsiCo International. I decided after that placement that I love food, which is why I now work in food. An emulsion is a system that's got oil and water. So it could be that it's an oil dispersed within water continuous phase, or it could be water dispersed within oil continuous. But in both of these emulsion types, there will always be an emulsifier which sits at the interface to reduce interfacial tension and produce smaller droplet sizes. The aim of my research is to make nanoemulsions, so I need to make the droplet sizes on the nanometer scale, so about 100 nanometer droplets. The reason that people care about nanoemulsions is that the size of the droplet produces some interesting sensory properties to the consumer. So they taste creamier, fattier, they have enhanced flavour release. Also, they have enhanced stability, so you can get extra shelf life from the product. The other thing is that you can have enhanced benefits with it, so you can start encapsulating nutrients, vitamins within the droplets, and they release quicker if the droplets are smaller. So there are 2 common methods of producing nanoemulsions at the moment in industry, and the most common way is a valve homogenizer, where the emulsion is increased to a pressure and then this pressure is released, and when this releases, flow becomes turbulent, energy dissipates and droplet breakups occurs. The alternative method is slightly different, and instead of forcing it through a gap and then forming jets, you force it through a gap to form 2 jets that then impinge on each other. This is a really good and exciting bit of equipment. It's recently patented. However, currently you can't scale it up. So there are industries that use it, for example, cosmetics and pharmaceuticals, because the flow rates for their production are a lot lower. One of my typical experiments is to produce a nanoemulsion on either of the 2 devices that I use. The one that I've used today was the microfluidizer. That's the high pressure impinging jet device. So we made the emulsion. We passed it through and collected it. The emulsion was a simple emulsion. It's probably the closest product that everyone is aware of to what I produce today. It's going to be a milk. Then once I've got the sample, and then take it across to the mastersizer. This measures the droplet sizes by using a laser and directing it at the droplets, and then by the amount that the laser diffracts, this indicates how large or small the droplet is. So I can tell minute differences in the droplet size distributions. I did the undergraduate degree in chemical engineering here, and I feel that it's helped a lot with the research that I've been doing now. So initially in the first year, one of the modules that's highly applicable is fluid flow, thermodynamics and heat transfer. So the fluid flow section of this module introduces fundamental fluid flow mechanics. And this has been really useful for me because I use high pressures, high velocities at small areas. So I look at relating and predicting what velocities I should be getting within my equipment. Following on from that, in second year I did a computational modelling module. I think it was called Computing for Design, where I learned about modelling flows. For example, I think I modelled a distillation column. But within modelling software, the equations are very similar and they operate in a similar way. So I've been able to use computational fluid dynamics to predict how the flow of my emulsions through my machines will affect droplet breakup. There's another module that really helped with this as well, with systems modelling in the fourth year, where there are a lot of fundamental mathematical equations. Following on from this, in the third year, there's a module called multi-phase systems. And so emulsions are a multi-phase system with the oil phase and the water phase. This taught the science of the interface between water and oil and how to reduce the tension between these phases to produce small droplets. And of course the aim of my research is to produce small nano-emulsion droplets. So collating all my results that I get on a day-to-day basis, I've been able to compare experimental results to the theory, so the modelling of flow that I was doing, to make the industrial used homogenizer nano-emulsion producer over 2/3 more efficient, which is saving the company a lot of money.